gather round, children, today. Instead of a math lesson, we will be having tales from beyond. Or, Megan, hit the lights. I guess we could just do a lesson on slope. That sounds like fun too, and potentially just as horrifying. Okay, let's keep going. Slope. Why are we learning about this in mathematics? Well, what we do here is we are taking the idea of slant or pitch or whatever you want to call it, tilt, grade, and we are assigning a number to something based on how slanted it is. And that's pretty useful. We can describe how slanted or how steep something is with just a single number. So that's the whole idea of slope. And it carries through many, many math courses after this one. So, where does it appear in your house? Why is this a practical application? There are so many things that require a slope or have code when you're building a home that require slope, like your stairs. They can be only so steep. An ADA, American Disabilities Act ramp, can only be so steep before it's too steep for people in wheelchairs to be able to go up it. All of these things have to be built to a specific slope or a minimum slope or a maximum slope. And so like your plumbing, is not going to be able to shed water or be able to pass your bowel movements down into the sewer system unless it is dropping at least a 1/4 inch every foot. So you need to make sure that there are slants in your home, and you need to be able to understand those basic things. Might even helpful even if you're just going to buy a home. So that's the practical application. Let's now look at it from the mathematics side. Before we begin, let's go ahead and review the basic vocabulary that we're going to need. So some people call this a graph. This thing is called the coordinate plane if you're looking for vocabulary. So if we're plotting points on here, like this point right here, right, you would write that as the coordinate plane. Okay, let's throw a couple points on here, and we will write those down here in just a minute. It's also called the Cartesian plane, but I'm just going to call it the coordinate plane or the XY plane in class probably. Okay, and we have our x-axis and we have our y-axis. The way that I remember is y to the sky. Now this is just like playing Battleship. For those that don't remember, feel free to skip over this if you do remember. If you want to plot a point or write these are the coordinates. Okay. If you want to write the coordinates of a point, you take where it lines up on the x value or on the x-axis. The x value of that, comma, where does it line up or where does it hit the y-axis here? So let's go ahead and write this one out. This one comes down the x-axis at 2 and the y-axis at 3, in between 2 and 4. Let's take a look at this point. This is the point. Where does it hit the x-axis? Coming down, -5. Where does it hit the y-axis? 2. Fantastic. And then down here, where does it hit the x-axis? Well, it hits it right there, which is 0. Where does it hit the y-axis? -4. Fantastic. This point here is the point 0, 0, and it's got a name. It's called the origin, for those that forgot. I'm going to be calling it the origin. You need to know that point is 0, 0. It's a nice little happy point. Makes me happy, at least, in many different ways. But that's besides the point. Okay, let's keep going. Okay, let's look at different kinds of slope. So any line that isn't vertical has a slope or a number associated with slope. So let's go over what those are. I'm going to use green. Come on, team. Here we go. Let's slowly apologize for the wait. Let's go down to green. So I always like to think, if you're riding a bicycle on this, would you be moving anywhere? No. Okay, so that means this slope is 0. This one, if you can't ride a bike on, it doesn't even make sense. It's not possible. So this is called undefined slope. Now on My Open Math, if you're using that and you submit a response and ask for the slope is, the answer is D and E, which stands for does not exist. Okay, so that's only if you're answering My Open Math. It is correct mathematically. This is also correct, but this is how My Open Math accepts its responses. Okay, apparently I added one too many letters there. Perfect. As you go from left to right on this graph, we are going uphill. So any slope that goes uphill as you go from left to right is a positive slope, and any slope that goes as you go from left to right, just like you read a book, goes downhill is negative slope. And I'm going to draw some other examples of what positive slope might look like. It could be really, really steep, or it could be really, really gradual, like this. It could be almost flat. If it's just a tiny bit sloping uphill, then it's got a positive slope. Okay, and same thing with negative. It could be slanted like this. So you're going downhill really, really steep, it's negative slope, or it could be, ooh, that is positive slope. It could be coming downhill like this. Perfect. Yeah, fantastico. All right, let's keep going. So I'm going to give you the formula that we'll be using today. If you have 2 points on a line, right, I'm going to call this point 1 and this point 2. We'll call this x1 comma y1, so that's the x value of point 1 and the y value of point 1. I'm calling this x2 comma y2. That is the x value of point 2 and the y value of point 2. Okay, now these little numbers down here are called subscripts. And a subscript is basically just a label. It has no mathematical merit. It's not like an exponent. It just basically, it's not an operation. It's just a label for something. You could put x with an A there, or just to label different things. So we're saying this is from point 2, this is from point 1, this is point 1, this is point 2, so on and so forth. Okay, now slope is a rate of change. It's written as a ratio. We use the letter m to represent slope, if you haven't picked up on that already. Okay, m is equal to slope, which the common phrase that we use is rise over run. Okay, rise over run. You also, so the rise, that means as I'm going from this point directly vertical, how far up did I go? So this is my rise right here, okay? Which the rise is also known as the change in y. So that little triangle is the Greek letter delta, which stands for change in mathematics. So it's the change in y over the change in x. Okay, so there's my rise. Here's my run, or delta x. Great. All right. So, so the slope is defined as basically this distance, this vertical distance divided by this horizontal distance. And we can actually use a mathematical equation to identify those two or separate them. All right, so you do y2 minus y1. That is, to find the distance, you would take this value y2 and then subtract this value y1 divided by x2 minus x1. So if you are given 2 points and asked to calculate that, that is the way it is done.
All right, so let's go ahead and keep going here. The marker's a little laggy. Let's hope that I'll try and finish up quickly if we can. Okay, find the slope of the line formed by points A and B. We'll call this point A and point B. If you want to know the slope of the line, there's a couple different ways that you can do this. The first way that I like to do it is by just remembering that equation, rise over run. Okay, so we're going to come back to this screen that we just saw, and we'll be referencing this throughout the lesson. Okay, when you're using rise over run, this is kind of like how we solve it graphically. So if you're given a graph, we kind of use this. If you're given points, or you would use this method. So this is if you've got a graph. This is if you're given, oh come on team, let's go here. If you're given a graph, this one is if you're given points. There's a lot going on that page. It's taken forever. Apologize for that. But anyways, we're going to keep going here. Rise over the run. So let's go ahead and go through here. What is my rise? Now basically, if you were to walk from this point to this point along these lines, what would be the vertical distance that you walk? Now we have to be careful here because you can tell really quickly that as we go from left to right, if this was formed a line, as we go from left to right, this is going downhill. So we're going to have a negative slope. So that's the first thing you want to think about. Is it going to be positive or negative? And then check your answer again when you're done. So we can go through and we can count. I go from 10 down to 2, or you can count 2, count the blocks, not the lines. 2, 4, 6, 8, right? So I'm going down 8, and as I go from this point to this point, I'm going down 8, but I'm going over 2. So what is my slope in simplest form? 8 divided by 2 is 4, so my slope is negative 4. Let's change color and do a couple more points. How about this one? How about between these 2 points? All right, if I'm going from here to here in green, my rise over my run, as I go to the, I can count this direction, right? Counting over and up. If it helps to draw some dots, that's fine. Just know that the line is actually right here that connects those two. Okay, so I go over 4, and this is also 4. So my slope in this case is going to be, as I go from left to right, it's going uphill, so it'll be a positive. And we put 4 and 4 to give us the slope of 1. Okay? Great. And then one more. Let's do maybe this one. All right, let's take a look. As you go from left to right, I'm going downhill, so my slope is negative. And then I'm going to use my rise over my run, that same equation. My rise, I fall 3, and my run is 2, 4, 6. So that will give us 3, 6 simplifies to negative 1 over 2. And that's how you do slope graphically. Counting these here. Okay, let's keep going. Sometimes you're given a graph. If you want to find the slope of a line, there's no points. You basically just pick points that you know it passes through. You can really pick any 2 points on the line. You could pick like right here and right here. The issue is you're not going to be super exact because those don't go through the grid mark. So you have to kind of do some reading, and then you'll end up with some decimals. It's going to be a little bit ugly. So instead, let's see if we can find points that we know it travels through. Looks like it travels through this point, this point, this point, this point, and this point. That's a lot of points. And you can pick any 2 of those that you want. It actually doesn't matter. So I'll show you. If you pick these 2, our slope is positive. As we go from left to right, it's going uphill. My rise is 1, my run is 4. So my slope there would be rise over run is equal to 1/4. Okay, now I can see that same pattern through every one of these pairs of points. But maybe you didn't see this point, or you didn't see this point. What if we actually look maybe from this point, right? What if we spotted this point and we spotted that point? We looked at those two. Well, let's count up. How far do I go up? I go up 3 and I go over, I don't know. Up 3 and over 6 plus another 6 is 12. So up 3 over 12. So in green, let's go team. M is equal to, my rise was 3, my run was 12. Boy howdy. So we are going to write 3 over 12, which simplifies to 1 over 4, which is the same answer we got before. All right, we're going to keep rolling because I think my computer is about to catch on fire. Yeah. One thing that is helpful to know, and you don't really need a graph to do this, if you have something that is flat, remember that is slope equals 0, okay? If you have something that is positive and at like a 45-degree angle, which means it goes up the same amount that it goes over, that is a slope of 1. So on a graph, here's my slope 0, here's my slope 1, but really these could be, oh my gosh, they could be anywhere on the graph. They don't have to pass through the origin. Okay, so that's like kind of slope 1, and that is slope -1. You can kind of see that. So here's slope 0, this is slope 1, this is slope -1. So anything that is steeper than this 1 is going to have a slope bigger than 1. Anything that's steeper and down in this region is going to have a low negative slope like -2. This might be like +2 or +3 or positive 500. That's also a possibility. Okay. Anything that's in this gap right here is going to be a slope that's between 1 and 0, like 1/2 or 1/3 or 3/5. And anything that is in this gap right here is going to be a slope that's negative, but a small number, like -1/2, -1/3, -3/4, things like that. So a good way you can guess. So like if I see a line that looks like this, I say, that slope is positive, but it's not as steep as a slope of 1, which is going up the same amount it's going over. This seems to be going over more than it's going up. So I'm going to say, in this case, you'd have that looks like a slope of like maybe 1/2 or 2/3 or something. So you can just take a guess, or you have a ballpark of what your answer should be before you even do your math. Don't worry about that. Okay, the next way that you can calculate slope is using that equation that I showed you. So if I said m equals y2 minus y1 over x2 minus x1. Okay, so the easy way to do this is to just copy those minus signs. That's the basis for the equation. I've done no math, and I always put parentheses. Okay, and what I go through is I go through and I just copy and paste the numbers that I need to, and I'll put them in the equation. So we'll call this 0.1. We'll call this 0.2 in red. All right, let's start with 0.2. Here is the x value of 0.2, and this is the y value of 0.2. So x2, y2. So y2 is a 2, so I'm going to copy and paste a 2 right there. And x2 goes down in the bottom under here, and that's a 3. Now I'm going to switch back to purple. Megan, can you get the fire extinguisher ready for my computer?
Yeah.
Thanks. X1, X2. Yeah, so let's go ahead. X1. It's been a long day. X1, Y1. Didn't do that in class today. I managed to capture it on the internet though. Y1 right here is going to be 7 if you're looking at this equation. And then down here, we have a minus sign, but we still need to bring, for x1, we still need to bring that minus sign along for the ride. So that is minus 1 as well. And now I'll switch back to green. Okay, and so we can continue on and we can now kind of simplify our math here. This is going to be 2 minus 7 is 2 good guys, 5 bad guys. We've kind of got, or 2 good guys, 7 bad guys, which means there will be 5 bad guys left over. Jump to the answer there. And then down here, we have a negative and a negative. The opposite of negative 1 is positive 1. So this is actually 3 plus 1, which is negative 5 over 4. So our answer is negative 5/4. Negative 5 divided by 4 is negative 5 over 4. Now you're probably wondering, Slagle, what if I had swapped these? What if I called this point 2 and this point 1? Would that make a difference with my answer? Well, let us see after this arrow is drawn. Let's just go ahead and plug in some numbers real fast and practice. Okay, what if these were swapped? We accidentally called this point 2 and this one point 1. Well, then that would be 7 minus 2. Come on, computer. Come on. Got the force. And then negative 1 minus 3. 7 minus 2 gives us a positive 5. Negative 1 minus 3. Those are both negative. So our answer there is negative 4. 5 divided by negative 4 is negative 5 over 4, so we still get the same answer. So it actually doesn't matter which point you call point 1, which point you call point 2. You'll still get the answer as long as you do your math correct. All right, I'm pretty sure this is going to break on this page if we try this again. So I'm just going to, holy moly, m equals subtract. I'm going to kind of cut corners here, guys, and not do the parentheses so my computer doesn't explode. So here we have, let's label these x1, y1, so if I can do that correct, and x2, y2. Beautiful. So now we can go through and plug them in using our equation. y2 is negative 8. Make sure you copy those negative signs along, even though there's already a negative sign right here. Y2 minus y1 is negative 2, divided by x2, which is negative 7, minus x1, which is 8. Now you'll see that the two ones that are from the same point should be kind of stacked on top of each other. If they're not, then you're not going to get the correct answer. Okay, now we can simplify this. Negative 8 minus negative 2, that's going to change the sign of the negative 2. So we will get a force. Jeez. Computer is lagging like crazy. Come on there, MacBook Air. Yes. Okay, we're good. Again, sorry for that, folks. Patience is a virtue. I will not say swear words on my YouTube channel. I will not say swear words on my YouTube channel. Okay, negative 7 minus 8. All right. So now we can simplify. So we change that to a positive. We have 8 bad guys, 2 good guys. Bad guys are going to win by 6. Negative 7 minus 8. That's a group of bad guys and a group of bad guys. So they are going to join forces of evil to form an army of negative 15. Now this can be simplified in more ways than one. A negative divided by a negative is a positive, and these are both divisible by 3. So that's going to be a positive answer. 6 divided by 3 is 2. 15 divided by 3 is 5. So our final answer is 2/5. Okay. This one is pretty straightforward. If you want to pause the video and try, please give that a shot. There are going to be more opportunities for you to do that. But yeah, go for it. I'm about to work it out. So the slope here is, again, y2 minus y1 over x2 minus x1, which is equal to, in this case, 22. Okay, if I call this point 1 and this point 2, that would be 22 minus y1, which is negative 2, and then down here is negative 24 minus 0. So 22 minus a negative will be a positive. That's going to end up being positive 24 over negative 24 to give us the answer, negative 1. Okay, you can try this one on your own next. This one is particularly funky. Give it a shot, lots of negatives, and then I'm going to work it out here in just a minute, so pause the video. Okay, here we go. All right. Again, y2 minus y1. I like writing it every single time, especially on on the homework, because it helps me to practice and memorize that formula. All right, let's go ahead and plug in. For y2, here's point 1, here's point 2. That's negative 19 minus y1 is negative 10. So you got to put make sure, I did those parentheses on the first example because it really helps you think about copy and pasting and ignoring that minus sign there. Okay, on the bottom, x2, that's going to be negative 5. And then x1 is 7. So let's go ahead and simplify these together. Lots of negatives here to get confused on. So it would be negative 19 minus negative 10 is plus 10. And then on the bottom, group of bad guys, which gives us negative 12. So we end up here with negative 9 over negative 12. And those are both negative, so our answer is going to be positive, and they're both divisible by 3. So that will be 3 over 4. Great. Let's keep moving, and we're going to go on to the tables. Oh, you do need to be careful on some examples. Like this one, you can try if you like. It's going to go fast. Point 1, point 2. Again, it doesn't matter which one is which. y2 is 8, y1 is 4. x2 is negative 2, x1 is negative 2. So what you have here is 8 minus 4 is 4, and on the bottom you have negative 2 plus 2, which will be 4 over 0. Now there's this mathematical law that says we can't divide anything by 0. It doesn't make any sense. So the answer here when you are dividing by 0 is, that's where we get our D and E, does not exist, or the slope is undefined. Again, your MyOpen Math answer is does not exist. Oh heavens. Come on, there we go. If for some reason you end up with the scenario 0 divided by 4 on a different problem, not on this problem, but if you end up with the slope 0 divided by 4, your slope is not undefined, your slope is 0. Important note. This is, you have 0 pizzas split amongst 4 people, how much does each person get? 0. This is, you have 4 pizzas split amongst 0 people, how much pizza does each person get? Well, first you said there were no people, and now you're saying there's people. We've contradicted ourselves. Doesn't make any sense. Okay, let's take a look at some tables. Finding a slope in the table is actually very simple. It is as simple as looking at how the table is changing. So if I come up through here, you can say, hey, I'm adding 3. How about over on this side in the x? Remember, slope is delta y over delta x. The change in y is always in the numerator, change in x is in the denominator. So here I added 2. Ladies and gentlemen, there's my slope. This is how y was changing, okay? This is how x was changing. So my slope is m equals 3 over 2. Now that's only true if you double check and make sure all your points are linear. So you have to be careful. You have to make sure that the change is the same for all of them. So let's actually check that. You should do that before you do your calculation. So right here we go up 3 and we go up 2 again. So the rate of it's still change in y over change in x is still 3 over 2. But check down here, this one's a little funky. We went up 6, and over here we went up 4. Well, that's okay, because it turns out if you do change in y over change in x, the slope is still 6 over 4, which is equal to 3 over 2. And you cannot see that because of my big fat face. So let me drag that over on the world's slowest computer. I think I maybe need to restart. Okay, let's take a look at this one. Okay, so change in, we'll call time is usually, that's fine. We'll call this our x. We'll call this our y. It actually is not a huge deal here. Typically this would be our independent variable. This would be our kind of dependent variable, for those that remember that vocabulary. So going up, change, we're increasing by 2, and here we are only increasing by 1. Down here, we are increasing by 4, and over here we are increasing by 1. You can stop right there, okay? When the slope is the same, when the comparisons are the same for all the points, this is called linear growth, okay? Now here, when I go up 2 and then I go up 1, this is, oh no, I'm way lagging, non-linear, okay? The slopes are not the same with each comparison. So here, between these 2 points, my slope is 2, and between these 2 points, my slope is 4. So what that means is, as time increases, the height is growing faster. The rate of change is not constant. Did I write the word? I did. Holy moly. All right, we're gonna take a look at one more example and be done. All right, maybe you got a leak. Maybe there's a leak in your house or something, and you wanna know the rate of change, right? It's not always just a slope on a graph, sometimes it's in a table. What's the rate of change in gallons per hour? If you want your answer to be in gallons per hour, it's the change in gallons over the change in hours. Well then, which one would be y? Remember, slope is delta y over delta x. So that tells us right there, if we want our answer in gallons per hour, gallons is our y, hours is our x. And then we can look, and you can go through and check and make sure that all of these have the same slope, which they end up, it turns out that they do. Here I'm going up by 3 in the x, and I'm going up by 9.6 in the y. So if you do the slope here, my slope is equal to the change in y over the change in x, which is 9.6 divided by 3, which is 3.2. That means the leak in your house is leaking 3.2 gallons every single hour. And if you check here, this hour increases, but this is 1 hour increase, and you've gone up by, you guessed it, 3.2. And this one is a 2 hour increase, and you go up by 6.4. So you can check that on your own. Ladies and gentlemen, that's the video. Thanks for watching. Sorry for the lag. I'm going to get that fixed. And I'll re-record it 12 times as a penance. Have a great evening.